Hi everyone, this is Dom Bettinelli, CEO of StarQuest, with a special message as we approach the Christmas season. This past year, the StarQuest network has continued to expand our mission of exploring the intersection of faith and pop culture through our many entertaining and informative programs. Now we need your generous financial support to reach new audiences with more of the life-changing and uplifting programming we've been creating for more than a decade. That's why it's very important that we hear from you this Advent and Christmas, the time when nonprofits receive most of their support for the year. If you are already a supporter of StarQuest, we thank you and ask you to prayerfully consider increasing your support at this time. If you're not yet a supporter, please become one now. Every gift counts. Could you give $15 or even just $10 per month? Whatever level of support you can offer, please show your support for SQPN this Christmas. And remember that your gifts may be tax deductible. Just go to sqpn.com/give. That's sqpn.com/give. May God bless you this Advent, and may you have a blessed Christmas season.
3, 2, 1.
We live in a universe of scientific wonders.
Every day, scientists are inching towards breakthroughs which can change our lives.
We're playing our small part in sharing these wonders with you.
That's why today is a fine day for science.
So let's science.
Caroline, why don't we throw it over to you now and do a bit of science? Okay, so we're still looks like we're still staying with space science this week. No, I can see the last. I'm looking forward to talking about that last one. But let's start with the space rock, and you can name it for us. So tell us about the space rock first of all that may be a piece of the moon.
Yeah, so it's a pretty rocky segment today, so bear with me.
Gosh.
Oh, yeah! Yes. So, guys.
Adria! Sorry, go for it.
So, a space rock called Kamo'oalewa may be a piece of the moon.
Cool.
Let's go through
wow.
that. So there's a space rock called Kamo'oalewa, and it's 100 meters across sized, and it's actually one of the Earth's quasi-satellites. Now, quasi-satellite is actually an object with a specific co-orbital configuration where an object stays close to the planet as they orbit the sun. So Kamo'oalewa actually orbits around the sun and then orbits a bit around the Earth and then back around the sun, right? So it's kind of classed as sort of like a near-Earth object. It was discovered in April 26th in 2016, and it was in images from the Pan-STARRS Observatory in Hawaii, hence the Hawaiian name for the big rock. Its orbit around the sun is similar to Earth's, with its year being about only 16 hours longer than an Earth year. And it's actually held in orbit by the Earth's gravity. And we were talking about gravity last week. It never goes further than 400 million kilometers from the Earth, or the most important part, it doesn't come closer than 14 million kilometers distance to the Earth.
Wow.
We definitely don't want it to come up and say aloha, do we?
No,
no, definitely not yet. No. Oh, well, not yet. Well, never.
We're quite happy with you where you are.
That's right.
Yeah.
And it's thought that Kamo'oalewa has been quasi-orbiting Earth for about a century, and it's expected it's going to do so for a very long time to come. Now, since this discovery, there's been a new research paper released, and it's pretty interesting because they think that it may be part of the moon. This journal article was published in Communications, Earth and Environment on the 11th of November this year, and it was led by Benjamin Sharkey and Vishnu Reddy. So they used the LBT, which is Large Binocular Telescope, and the Lowell Discovery Telescope, LDT, to observe the satellite. It actually becomes bright enough to observe every April. So they know when it's coming round, and they're able to put the telescope on and have a good look. And both telescopes do something a little bit different. So the LBT was used to obtain broadband color photometry and visible spectra. So, being able to see it and then look at it in the visible spectrum of light. And it did that on the 14th of April, 2017. And it also had a MODS spectrograph for imaging and stereoscopic images. So it looks at it at like sort of, as a stereo image. So it's one image on one side, one image on the other side sort of thing, to make observations. And it was observed in visible and also in near infrared light. Follow-up imaging was made using the LDT on the 18th of April 2017 to collect information on signal-to-noise ratio data, which provides information about the light curve and rotation of the object. And the light curve really means the brightness of an object over a period of time and the surface brightness of the object.
I was going to say, Caroline, that is some great Star Trek techno babble you got there.
I know. I'm
Although
trying
this is
to
real
explain.
science, not babble.
It's true. I'm trying to explain a little bit as I go. So just to,
that's awesome.
yeah. So it's not just blah blah.
No, of course not.
So and the infrared imaging is really good because it actually helps to distinguish a body as a moon, an asteroid, or a terrestrial planet. So it gives that extra information. Now, what did they discover about Kamo'oalewa? So let's go through it. And I went through, there's lots of articles, but I like to go to the journal articles, so I picked out a few good points.
Yeah, they're the good ones, yeah.
It has a light spectra similar to that of lunar rocks brought back to Earth in the Apollo missions. The spectral properties, which are the characteristics observed when viewing the satellites at different wavelengths. So again, the different wavelengths will give you different properties, like different clues to the rock. They're very similar to that of the moon. Sharkey, one of the researchers, said that it's not that there couldn't have been other asteroids with such spectra, but we haven't found anything so far that looks similar to it. That's why it's so special. No other asteroids that they've viewed have had these particular properties. Kamo'oalewa reflected more sunlight at longer or redder wavelengths, which looked unlike any observed in any other near-Earth asteroids. However, it did look like grains of silicate rock from the lunar samples. To get to the real detail, they had 19 lunar samples, and they compared it with the spectral properties of the sample of not the samples, but the viewing of the properties of Kamo'oalewa, and they found that the 20 to 40 micrometer grains, so that's the size of the grains on the Apollo mission rock samples, they actually had a close match to the light properties of Kamo'oalewa as they viewed them, which is pretty cool.
Yes.
So what are we really saying? What are we concluding about this? So they're saying that Kamo'oalewa could have, so these are the conclusions in the report. It could have been captured along with other near-Earth objects. However, its orbit is not like that of other near-Earth objects, so they're thinking maybe not. It could have come from a yet undiscovered quasi-stable population of Trojan asteroids, which are asteroids that actually orbit the sun in the vicinity of the Earth. Don't worry, it's a very stable orbit, so they're not coming close, right? They just have a very similar orbit. But they're saying that this would need more research and more observation of the pathways of the asteroids to see if it actually came from that group of unknown Trojan asteroids. And then the third and most favored by the research paper and science articles, because it is the most exciting conclusion that everybody wants to come to and they're going to test for as well, is that Kamo'oalewa could be ejecta from the moon's surface. So the moon is covered in thousands of craters, so it could be that Kamo'oalewa is the first bit of moon that's actually been found in space from one of its ancient collisions.
Oh, wow.
Has not had any recent collisions, just to make that clear.
That's good to know. That's reassuring.
That's right. On a side note, about 480 lunar meteorites have actually already been found on Earth itself. So we've got good samples from the Earth and from the moon itself. And so they're hoping to actually sample the Kamo'oalewa, and China actually going to be launching a mission in 2024 to attempt to collect a sample from the Kamo'oalewa surface and bring it back to Earth so that we can further compare it to the moon samples, and then you can do so much more, actually visually look at the sample and then do all these other tests to confirm to see if the composition is the same as the moon rock samples. So I thought that was just super exciting. Imagine if there is a bit of the moon floating around that we didn't know about, or, maybe there's heaps of it and it's just we haven't seen it yet. So we just don't know.
It'd be an amazing find. I mean, it's not exactly, you randomly just find a piece of the moon floating around somewhere else, in the solar system. It'd be an amazing discovery to say, yeah, we can confirm that this is a piece of our moon from a long time ago.
That's right. And it's not something they were expecting, because they do study, the near Earth objects quite a lot, using telescopes and things. And then when they found this, when they found the light properties of this, and, go, oh my goodness, it's the same. It's very similar to lunar samples. I mean, that's just amazing, isn't it?
It's brilliant. Yeah, and I love that that now we're seeing all of these missions. They're not, they're no longer just probes that go around planets or moon landers, which are all really good. But like now we're sending things to asteroids, and we're collecting samples, and we're firing at them, and racing, but not racing buggies on them, but like we're putting little landers on them, and all these great discoveries. Do you have anything else to say about Kamo'oalewa? Because I want to segue into the next one when you're ready as well.
Yeah, no, I was just going to say that these types of missions, just to go on what you were saying, is that it does give us clues to the formation of our solar system and the formation of planets and all of that kind of thing. So every single bit of, every single test that's performed, every experiment, every bit of information that we get, it all adds up, and we can build up a bigger picture. I mean, imagine that the textbooks of the future are going to have all this amazing information, a lot more than we had when we were doing science at school. So it's just really cool.
Yeah, the clues are right there for us to go and visit and pick up from. Yeah. So Caroline, let's segue then into the other side of this, because it's great that we have all these asteroids, in the solar system, but one day there could be one that decides that it does want to get a little bit closer to Earth, and we don't necessarily want that, because we like living. I hope that doesn't upset anyone, but we like being alive.
We love
solar
our
system.
planet.
Yeah. So if any aliens are listening, we just like existing. So
they are. They're listening.
Yeah, they're listening. Yeah,
they're
great
watching.
audience, by the way. Yeah.
Yes.
Yeah. Strange feedback. I can't translate it, but anyway. So NASA launched this awesome mission, which I loved watching. I actually had to watch a replay because I didn't get to watch the launch live. It was a SpaceX launching NASA's DART mission. So Caroline, tell us what DART is doing in order to defend our planet.
Okay, this is really cool. This is actually the first one of these missions, okay, they're actually going ahead to test the possible redirection of asteroids. So this is the DART mission, the Double Asteroid Redirection Test mission. It's through the Johns Hopkins Applied Physics Laboratory and the Planetary Defense Coordination Office in NASA. So this mission is to test a method of planetary defense of near-Earth objects by crashing an object onto it. In this case, it's a little space probe, and they'll be using the kinetic impactor technique. They want to test if by crashing into a near-Earth object, the momentum will be enough to change the motion of the asteroid, which may be heading into Earth's direction. So really, they just want to knock it off course and see if they can do it.
They're playing pool, but
it's not the same pool,
intergalactic pool. Yeah,
a little bit. So it launched on the 24th of November. This year from the Vandenberg Space Force base. I love saying that.
Space Force.
Space Force. And collision is due on 26th of September 2022. So we've got, sort of a bit less than a year until we know how the collision went. So it's aiming for a double asteroid system of Didymos, and it's got a little moonlet called Dimorphos, and that's what they want to knock off course. They want to try and knock the moon off course a little bit. They'll also have a CubeSat watching from a distance and capturing footage of the event, because the probe
So
itself
cool.
is actually going to be destroyed. And and so it's basically they're launching this probe. It's got these solar arrays that actually roll out, which is another technology.
Yeah, which is cool. Yeah,
that's pretty cool.
Just quickly, we've seen that on the International Space Station
That's
recently.
it.
I think
Yeah.
earlier this year they installed those and they did the rollout. That they connected them up and they
That's
just
it.
roll out on their own, which was really cool.
Yeah. It's good space saving technique, really. Isn't
Really
it?
is, yeah.
It's really good.
Yeah.
And so obviously they're gonna, there's only a camera on the probe, so you'll see it move, going closer, and then nothing. So what they're doing is launching a CubeSat as well, which will be viewing the whole thing from a bit of a distance, and they're going to be able to see what happened. Now they've stressed that this is far away enough from Earth that if they knock it off trajectory too much, it will not start heading towards Earth, which is kind of the
That's good to
opposite
know.
of
That's
what
good
they
to
want
know.
to do.
Yeah.
Because you don't knock the 8-ball into the pocket first. That comes
That's
last.
right. That's exactly right. And then to confirm whether they've actually knocked it off trajectory, another method to see if they've managed to do it is to measure the change in light as dimorphos orbits Didymus. So at the moment they're able to view it's kind of a speck of light in the sky, and they see the moon going around, and then they're able to measure the light coming from it and and the light properties again. So they'll be able to take measurements, compare them to before the probe crashed into it, and then see if any change was made. So I mean, another super interesting experiment being done out in space.
Yeah. And if things don't go well, we can always send Bruce Willis and a team of oil miners
always.
on a special ops mission to drill a hole, put a nuke, and blow it up. I mean, there's that too.
You forgot the other method, which is Superman.
that's true.
We've got Superman.
Yeah,
that's true. Yeah,
We can do that. We could try that.
I think Iron Man might be available at some point if we
He
need him.
might.
Yep.
He might.
Mm.
He's a bit
Is he-
fragile though.
Oh, yeah. That's true. Wow. Oh, wow.
Don't we have a giant space laser somewhere? Has that happened yet? Or
Hmm.
I'm not 100% sure about that one.
Not by,
What,
not that we know of. I think.
Are you telling me
That's
these things
a
are all
good
fiction?
answer. Yeah. I think not that we know of is probably a good answer to that one.
Yeah.
Wow.
Yeah. So Caroline, just quickly as well. So I mean, because the question might be, why don't we just fire a missile or a nuclear missile or a laser or whatever else? So what would be the unintended consequences if we did that?
Well, I think it's probably quite evident what may happen if you fire a nuclear something into the
In space.
into
Yeah.
space, not into the atmosphere. That's how they work. No, into space, and just say it went wrong and fragments went everywhere, and you had a few more meteorites, and other larger objects heading to Earth than you really wanted. And then maybe there would be a big game of pool in knocking things out of the way. And I mean, we've got the space station up there. We've got actually two now. We've got China and we've got the International Space Station. There's a bunch of satellites. Like, you just don't want to create any fragments anywhere. And I just don't like the idea of nuclear anything being shot up into the sky.
Yeah, that's also,
anyway.
I mean, there's that too. Yeah, if it
Yeah.
goes wrong.
It's
Yeah.
true. That's true.
That's not a good idea. So, yeah. So, yeah, they're trying the pool effect.
Yes. Yeah.
Yeah.
All right. Well, Caroline, thank you so much for rocking our world with that segment.
Let's Science is brought to you by StarQuest Media and is a fortnightly podcast that brings you the scientific wonders of our universe from a distinctly Catholic point of view. For more from Caroline, Lindsay, and friends, listen to the StarQuest show, Catholics of Oz. Find links from today's show at sqpn.com/science and find the Catholics of Oz at sqpn.com/Oz. Be sure to follow the show in Apple Podcasts, Google Play, wherever you can find podcasts, or on the SQPN YouTube channel. The generous donations of our patrons at sqpn.com/give make it possible for us to continue Let's Science and all the shows at StarQuest, which makes our nonprofit mission possible. You can join them by visiting sqpn.com/give. Join us next time for more scientific wonders, and thank you for listening to Let's Science on StarQuest.